Hello everyone, MK's here. This session I will be discussing Diophantine equation with you. Solution of the equation was initiated by Greek mathematician Diophantus. That's why it is named after him. He initiated the solution. Many people have worked after that. Question is, what is the Diophantine equation and how to solve it? Before we start the session on solving linear Diophantine equation, let me remind you two important concepts we need from our previous discussion, like GCD of two integers always can be expressed as linear combination of those two integers. This I showed you with solving few examples. I hope all of you remember. GCD of two integers equal to 1. This implies that they are co-prime numbers. I'll tell you to remember these two things only before we start Diophantine equation. So which two facts you have to keep in your mind? GCD can be expressed as linear combination of two integers. We find GCD of two integers only here in number theory. And then if GCD of two integers equal to 1, the linear combination of those two numbers also will give you 1. Let us start to understand solution of a Diophantine equation. If we see the learning map, we are going to learn following topics. Introduction to Diophantine equation, historical context, already I have mentioned. No need to understand the solution of Diophantine equation, but you must know the person who worked behind this for a long time. Its importance in algebra and number theory, just to solve equations. Then when you are solving linear Diophantine equation, you need to follow some detailed steps. First, check solvability, find a solution, and then find the general solution. I'll explain all these. And these three sums I kept ready for you to practice at home. I hope you have practiced sums in the last worksheet. Link is given in the previous video description section. Please go through, please download and start solving it. Then a fixed time for your preparation for Olympiad or JEE examination. As a student, you need to excel in all mathematics examination. As a maths lover, this is your basic aim. So basic responsibility also there. You solve few assignment problems. I'm not telling you that whole day you solve Olympiad problems only, but you definitely solve the worksheets I'm sharing with you. Origin already told, named after ancient Greek mathematician Diophantus of Alexandria. Historical significance, Diophantus is often referred to as the father of algebra. His work laid the foundation for algebraic notations and the study of integer solutions to equations. And what is the importance? They have application in number theory, cryptography. The most useful part of number theory nowadays, cryptography, and many other areas of mathematics. So significant, it is obviously a significant topic which we are going to learn today. And then know what is a linear Diophantine equation. This is an equation of the form ax plus by equal to c. Most of you have done plotting of this kind of equation in class 8, 9, 10 level. As I know, if I am wrong, you should mention it. How to solve, how to plot the graph of this equation that you know. And when you plot, then you get infinitely many solutions. On a straight line, all the points on a straight line is a solution to the equation. When you plot the graph of this equation, this linear equation, we are doing linear Diophantine equation only today, then if you plot it, you get many points on this line. All those points are solutions to this equation. Ax plus by equal to c. A, B, C are integers, x, y are variables that take integer values. And objective is what? To find all integral solutions that satisfy the equation. Here you can get many solutions. When you are writing an equation, say of the form 2x plus 3y equal to 5. You cannot say that I'll get integer solution only like x equal to 1 and y equal to 1. Of course, this one is a solution. But many other solutions are there. The way normally you do, you express y in terms of x. 3y equal to 5 minus 2x. So y equal to 5 minus 2x by 3. For x equal to 0, if you put x equal to 0, y is coming to be 5 by 3. But this is not solution we are searching for. Diophantine equation will give you integral solution of this form, x equal to 1, y equal to 1. And you cannot say that there is only one solution like x equal to 1, y equal to 1. Many solutions. Many are there. Okay, you just go on putting some value of x and go on checking what are the values of y coming. We can get solution integers, many values. Our interest in today's class to get the integral solution. Understand what I am saying? We will not plot, we will not find this kind of solutions. We will find just this kind where integral solutions are there. And you see there are infinite number of points on a straight line. So if you say that there is only one solution, then it will be wrong. If I have not given you any restriction, then one solution you said it's fine. Otherwise, infinitely many integral solution also possible. So you understand what is the meaning of solution? Solution of an equation are the values of x and y which satisfies the equation. This equation satisfied by x equal to 1, y equal to 1. So this can be referred as solution to that equation 2x plus 3y equal to 5. Okay. So we are in need of getting integral solutions from here. Why is it different from other equations? These are the main parts you should remember. Integral solution only, that I was telling you. Solution will be all integers. Unlike regular linear equations, if this is a regular linear equation, you will get many solutions like this. Diophantine equation requires solutions to be integers. That I am telling you repeatedly. Now, existence of solution. If an equation is given in this form 2x plus 3y equal to 5, then you will definitely get a solution. But somebody has given you equation of this form 4x plus 8y equal to 19, you will never get integer solution. Why? Because left hand side 4 into x, 8 into y, both are even numbers. Right hand side is an odd number. Solution not possible. Okay. So existence of solution will be there if the GCD of these two satisfies this, the right hand side. Here GCD of 2 and 3 is what? 1. 1 divides 5. But here GCD of 4 and 8, 4. 4 does not divide 19. So you will not get an integral solution over there. You understand what I am saying? This you need to check before you solve the equation. Solving equation means what? I remind you again, getting values of x and y. Am I correct? So, for solving this kind of equation, ax plus by equal to c, we need to check GCD of A and B, I mean HCF of A and B. If it divides C, then it's fine. If it does not divide, then you reject. You state that solution in integer not possible. Infinite solutions. Now, one of the most important characteristic of Diophantine equation is that, and we'll prove it also today's class, if you get one solution, then you'll get infinitely many solutions. Okay? This equation doesn't have any solution. By putting any value of x and y in integer, you'll never get 19. So there is no expectation of getting integral solution from here. But here, 2x plus 3y equal to 5, here we will get infinitely many solutions. Because first thing, GCD of left hand side, that 2 and 3 is 1, 1 divides 5. And another thing, we have proved that a solution is x1, y1 satisfying it. Those two in future will refer as x0 and y0. This will be starting solution. I mean, one solution I know initially, that will be referring as x0 and y0. So in our problem, x0, y0, 1 each, maybe x0, 1, y0 equal to 2. So solution is possible and we'll get infinitely many solutions. We are in search of finding that how infinitely many solutions we can get from Diophantine equation. Okay? Now, step by step procedure. Just what I was telling you, I have listed again. I have written before starting the class because it will reduce the timing. Okay? Otherwise, length of this session will be very long. That I don't want. So what you have to do there first, whenever you have an equation like this, ax plus by equal to c, you need to find the GCD of AB. Check whether it is dividing C or not. If it doesn't check, if it doesn't satisfy, then you don't proceed. Clear? Telling you repeatedly. Find GCD of A and B. If it divides C, then only you can go for integral solution. Otherwise, you will never get. Then find one solution. That solution will be referring as x0, y0. I told you earlier. And then go for general solution. This step I need to discuss. That's why I did not write anything. I have to discuss in details here. Okay? Before I start solving a problem, I have to remind you one very important thing, that concept of GCD, which we have done in the first session. GCD of two integers a and b, we write as d. Then this will imply what? This will imply that number 1, d divides a, you know, and d divides b. Another condition I told you, that also I will remind. If there is another integer which is not equal to d, if c divides a and c divides b, then c must divide d. This I told you last class also. Remember it? With example. Please go through the video if you need. Okay. So the concept of GCD was a reminder for you that you need to remember this concept. Another reminder I give you, reminder 2, that is GCD of A and B. GCD of A and B can always be expressed as, A and B are integers, never forget that. Can always be expressed as linear combination of A and B, where x, y belongs to the set of integers. Those who don't know this symbol, just remember x, y are integers. GCD between two integers a and b can be expressed as linear combination of these two. And another thing, if A and B are co-prime, then GCD of AB equal to 1, and that must be equal to AX plus BY. That GCD also, this is common theorem, no? Bayes out theorem, I told you. So if they are co-prime numbers, GCD 1, then 1 can be expressed in the form AX plus BY, where XY belongs to I. Am I correct? You understand? Now let us take one equation to solve by remembering these 3 steps. You never forget. I'll share the note, class note with you. If you need, you must write in description box. Link I'll share. Otherwise, I'll share the problem sheet only. Okay. So you are going for checking the solvability, then one initial solution, then general solution. See, I'm going to solve. How? Now, to solve the equation like AX plus BY equal to C, when you are going to solve, this C must be divided by GCD of A and B. Assume that this condition is obeyed. Let AB, GCD of C, GCD of A and B divide C. This is the symbol for division. Then what is the next step? Find one solution. That will refer as, let this equation 1 be satisfied by for x equal to x0 and y equal to y0. Satisfying means this equation will be satisfied for x equal to x0 and y equal to y0. So what will you get? Ax0 plus by0 equal to c. I'll show you example. Let me discuss the common method first. So from 1 and 2, what do you get? If you compare 1 and 2, from 1 and 2, you see the right hand side, they are equal. Ax plus by equal to Ax0 plus by0. Now this is Ax minus x0, b y0 minus y, that you know. Because we have transferred by on right side, we are getting Ax minus x0, by0 minus y. Now, these two integers, A and B are, we have assumed that GCD of AB dividing C, and then let GCD of A and B equal to D. Let. Then how can you write A and B? Then A will be equal to P into D and B equal to Q into D, where P, Q are also integers. You agree? This you know. And another thing is clear that P and Q do not have any common factor. A you have written P into D, B you have written Q into D, it's fine. But P and Q, their GCD will be equal to 1. So that we write here that GCD of P and Q equal to 1. Now from this equation number 2 or 3, whatever, you just use this one. From 3, I am discussing common method. Definitely I'll solve problems. From 3, what do you get? PDX minus x0, QD, y minus y0. D and D get cancelled. So this implies Px minus x0, Q, y minus y0. It is quite obvious that p does not divide q or q does not divide p. So what is true from this equation? That p, as p does not divide q or q does not divide p. So this implies that p divides y minus y0 and q divides x minus x0. Otherwise equality will not be valid. So this implies that from here what can you write? I want integer form. So what I'll do here, I'll be writing x minus x0 by q. That q we are taking here on left side and this p we are taking on right side. It is y minus y0 by p. They are both integers. We have claimed that p doesn't divide q, q doesn't divide p, so q must divide x minus x0. We'll get an integer on division. We'll get an integer on division here. And that integer, they're equal. So let it be equal to t. Let this thing equal to t. Assume. You are just assuming it. So this implies what? X minus x0 equal to q into t. Y minus y0. Wait a minute. Probably it is going to be y0 minus y. So it is not y minus y0. Copied it wrong from the previous step. It will be y0 minus y. Okay. So this will be y0 minus y. Let me correct this part. And here also it is y0 minus y. So y0 minus y equal to p into t. So you write p into t. Therefore, x equal to x0 plus qt and y equal to y0 minus pt. Clear? Now previously we have taken a equal to pd and b equal to qd. Put it there. What does this imply? That p equal to a by d and q equal to b by d. Then solution is done. Therefore, x equal to x0 plus q is how much? Just have written q is b by d. b by d into t. This t, remember, t must be an integer. It is very, very important because all integers we are getting. T is an integer. Okay. So x equal to x0 plus bt and y equal to y0 minus a by d into t. These are two solutions of the Diophantine equation. When you are going for IUQM examination or JEE examination, there you will face MCQs. You remember the fact and write the answer. But there is one problem, that x0, y0 might give you trouble. Finding x0, y0, what to do? That will be done with the help of extended Euclid's lemma. Last class I showed you how to solve an equation like 3x plus 7y equal to 1 or 10, whatever. How to solve that I told you. Okay. So I'll show you in details in one equation at least how to get the solution. Say this question, find the general solution and the least integral solution of this equation. We have to solve it. So what was the step 1? I remind you. GCD of 12 and 17 or minus 17. You say minus 17, no problem. This is the positive integer, you know, that's why you will write 12 and 17. This is 1. 1 divides minus 1, isn't it? So integral solution is possible. What is the step 2 here? Step 2, find the initial solution. What value of x and y will satisfy initially? Let us do it. You do it. I remember the solution. I have solved it before. So I put the initial solution. Okay? Don't mind. Okay, let me solve it for you. We are going to express 12 and 17, the GCD as linear combination of 12 and 17. That will be the initial solution. What is 17 over there? 17 is 1 into 12 plus 5. 12 is what? Extended Euclid's lemma. I told you it is very useful. 2 into 5 plus 2. Then interest with 5 and 2. 5 equal to what? 2 into 2 plus 1. Then 2 is 2 into 1. Done. So GCD is 1. Now for the elementary solution, that is initial solution, we will use reverse Euclid's lemma. Start from here. What is 1 over there? 1 is equal to 5 minus 2 into 2. What do you get from here? 2 equal to 12 minus 2 into 5. Just substitute there. 5 minus 2 into, you need what? You need the value of 2. You just put this value of 2, that is 12 minus 2 into 5. Okay. So this is changed to 5 into 5 minus 2 into 12. From here, what do you get? 5. 5 is what? 17 minus 12. You put it there. 5 into 17 minus 12 minus 2 into 12. So this is done. What have I got? I got 5 into 17 minus 7 into 12. So GCD 1 expressed in this form. But we need minus 1. So multiply both sides by minus 1. It is going to be 7 into 12 minus 5 into 17. Hope you have understood the initial solution. What is the initial solution going to be then? X0 equal to what? Tell 7 and Y0 for this equation equal to 5. This equation was, wait a minute. This equation was 12x minus 17y equal to minus 1. What have I got? The initial value, that x0, 7 and y0 equal to 5. Really, 84 minus 85 is minus 1. So this is your initial solution. Then what to do? I'll show you that step with the numericals which we have done before. The next step will be step 3. We are going to write 12x minus 17y as 12 into 7 minus 17 into 5. Isn't it? You understand what I did? So this implies 12 into x minus 7 equal to 17 into y minus 5. You can see GCD of 12 and 17 is 1. So 17 must divide x minus 7, 12 must divide y minus 5. Otherwise it will not be true. So this you write x minus 7 by 17, which is going to be an integer, y minus 5 by 12, same integer that you write as t. Therefore we get, wait a minute, check the step. This is correct. So you compare x minus 7 by 17 with t and then this thing with t. So what does it give? If you write x minus 7 by 17 equal to t, this implies x equal to 17t plus 7 and y equal to 12t plus 5. This is the solution where t is an integer. No restriction on it, any integer possible. Any integer will give you one value over there. Clear? Now the question was, if you took t equal to, if you have taken t equal to 1, then it is coming 24 and 17. That is one solution. If you take t equal to minus 2, t equal to minus 2 means minus 27 and minus 19. That is also a solution. So take any integer value of t, you will get a solution. Let us see the next part. Find the least integral solution. How will you get? After getting this solution, which one least integer? Is it 7 and 5 only? Maybe, may not be. You may suspect this is not the least value. Maybe other values are there. Let's check. So what we'll do there for least integral value? For least positive integral solution, x greater than equal to 0, y greater than equal to 0. This implies 17t equal to 0, not for positive. Okay, I have taken, not changing. Greater than equal to 0 and 12t plus 5 greater than equal to 0. What does this imply? This implies that t greater than equal to minus 7 by 17. And here t greater than equal to minus 5 by 12. Clear? So on the number line, which one is larger? This one larger, 5 by 12 is larger than 7 by 17. Am I correct? So this implies if you multiply by negative sign, minus 5 by 12 will be less than minus 7 by 17. So minus 5 by 12 will be lying here, minus 7 by 17 on the number line. So greater than minus 7 by 17, greater than minus 5 by 12 means the least integer value is going to be equal to 0. T is going to be equal to 0. Clear? So that t must be equal to 0. Clear? The least positive integral value, I am taking t equal to positive number, not 0 only. Is it? Because just after fraction, a proper fraction, negative quantity, the next integer will be 0. So we will be taking t equal to 0. For t equal to 0, the solution we already got, x7 and y5. This ensures that it was the least positive integral value. Clear? Let us take another example. Find the general solution and the least integral solution, least positive integral solution. I am not considering negative integral solutions. Least positive integral solution of this equation, 35x minus 13y equal to 10. How to solve it? 35 and 13. Let us go by steps without wasting time. What to do here? Step 1, GCD of 35 and minus 13 is GCD of 35 and 13. This is equal to 1. And 1 divides 10. So, integral solution is possible. Possible for what? For this equation. Yeah, this is possible. At least we can say that integral solution is possible for this equation also. 35x minus 13y equal to 1. You agree or not? GCD of 35 and 13 minus 13 is 1. So this equation has a solution, 35x minus 13y. Clear? Then we will be using this equation. Multiply the right hand side by 10. What is the initial solution here? That is the question. Finding it will be easier. Keeping 10 over there will be problematic. As I know by the theorem that if GCD equal to 1, two coprime numbers, that 1 can be expressed as linear combination of the two given numbers. So I can make use of the fact. So 35x minus 13y equal to 1, I am giving the general solution first. and this time I am not going to do it by extended Euclid's lemma. Should I do? No, you try. Okay, I just see the solution here. X equal to 3 satisfying this 105 and y equal to 8. So for this one, this calculation, this observation implies that 35x minus 13y can be expressed as linear combination of 35 and 13. What is that? It will be 35 into 3 minus 13 into 8. But you are asked to solve this equation 35x minus 13y equal to 10. This one you got so nicely. You must go for 10. Okay, let us take this equation into consideration now. Given equation is 35x minus 13y equal to 10. 10 means 10 into 1. And 1 is this thing, 35 into 3 minus 13 into 8. Done? Because 1 we have written this form, no? 35 into 3 minus 13 into 8. 105, 104. Done. So, 35x minus 13y is equal to what? Just write 30 into 35 minus 80 into 13. Clear? Now take all 35s together on left side. So it will be x minus 30 into 35 equal to 13 into y minus 80. Obviously 35 and 13 they don't have common factor. So dividing one of them by the other is not an integer. So what I'll do, I am in search of integer. I'll write x minus 30 divided by 13. 13 must divide this one. And 35 must divide this one. Y minus 80 by 35. They're equal. They'll give you the same integer t. Say t is an integer. So from here x coming to be 30 plus 13t and y coming to be 80 plus 35t. Clear? So this is the general solution where t is an integer. T belongs to I, you write this way, or t is an integer. Clear? Any integer you get, this is the advantage. You will get a solution to this equation. You check it afterwards. Now for least positive integral solution, what to do? For the least positive integral solution, we write x greater than equal to 0, 30 plus 13t, t greater than equal to minus 30 by 13. This implies 80 plus 35t greater than equal to 0, t greater than equal to minus 80 by 35. Clear? So, if you plot on the number line, which one larger? This is, check which one larger. Now, I have written opposite. This is less than this. So, this implies minus 80 by 35 is larger than minus 30 by 13. On the number line, if you plot minus 30 by 13, it is minus 2 point something. This is also minus 2 point something. So next integer is going to be equal to minus 2. So you take that one, minus 2. Minus 1 come later, 0 come later. So t equal to 0 will not give you the initial solution. T equal to minus 2. Now for t equal to minus 2, let's see what happens. For t equal to minus 2, x will be 30 minus 26, that is 4. and y will be 80 minus 70. This is equal to 10. Therefore, x4 and y10 is the initial positive solution. Clear? Hope you have understood. So this is the method you have to solve Diophantine equation. I hope you have understood. Practice sums at home. From where? Those 3 books I have referred, many problems are given over there. You start solving from there, and I am going to share assignment on Diophantine equations that you must practice for Olympiads and for your future JEE examinations. Okay.